Hello everyone, welcome to our discussion of Module 6, which centers on data transformation in data science languages. We'll go ahead and get this started. So jumping straight in, swap monitors. So our agenda, very similar to every time. We'll talk about Module 6, talk a little bit about the reading, Python and R, showing some examples as we go. So Module 6 is all about data transformation, something you've been doing a bit about already, but in this case we're actually going to do a little bit more and do some derivations of some new data. And that's a very common thing to do. It's essentially feature construction is the technical term. What you're doing is you're taking potentially multiple, could be a single, but you're taking something, an attribute of an existing data set, and then you're going to derive something from it or from multiple ones. A classic example is date time, right? So oftentimes you'll get files that have date time stamp information inside of them. You generally will need to take that and convert it into potentially things like year, month, date, each one of those being distinct features, and potentially time as well. So those are all things that are done in a common way. In this case, you're talking about determining how many shares of stock could be purchased based upon a monetary limit. So you're taking the stock price and then deriving something different from it based upon a certain dollar amount. So we'll go ahead and talk a little bit about the reading. Chapters 8, 10, and 12 out of the Python book, and chapter 7 and 13 out of the R book. Some of these are pretty relevant. Some of them are a little different. Obviously, cleaning and transforming is very relevant, as is joining, combining, and reshaping. Those are very common sort of things we do as well. So whenever you talk about data transformation, there's some basic steps that we typically follow. You always start by reading the data frame, and then there's probably a 1A there where you do some inspection of the data frame and maybe even have to do some cleansing of the data, potentially looking for missing values and, if possible, inferring an appropriate replacement for the missing values, or potentially excluding the data from the data frame that is not all there. That's a very common sort of thing we do. Anyway, so it's a good idea to be in that habit. So the basic idea is you read the data into a data frame, you join data so it is comparable, and then you create any new columns such as an average, and then you do some joining using the merge command, create a new data frame, determine if the question can be answered. You're probably doing that earlier whenever you're actually selecting the data to load. You're probably figuring out what data files have the data that you're looking for, and then solve the question by using the appropriate formula, and then you may want to produce some sort of output, be it either a graph or potentially just the data. Fairly common steps we go through. So first we'll talk a little bit about strings. I've talked about these before, but it is something that is very important whenever you're doing any kind of textual processing. You'll be doing this sort of thing. The various commands, and there are a lot of them, but the common ones you'll use are things like find. Sometimes you need to know the length of a string, how many characters are in it. Then you sometimes want to convert an array into a string, so you do a join, and sometimes you want to go the other way where you want to split them out using a split sort of approach. So in this case what we're doing is using the separator dot join, and it doesn't have to be a character or a variable. It could just be the string itself. In this case I'm making it very clear that there's a string that is using the join. Split kind of does the reverse. It takes a string and returns an array. And then there's also substring operations where you can go through and access portions of the string using our colon notation, which we've seen in lists and a few other things as well. So that's that. I'll go ahead and switch over and do that real time, which is always exciting because there's always the chance of glorious failure. So let's see, hopefully it's in here. Python string functions. And again, what we just saw, here's find. We're looking for a string. If it's not present, it returns a -1. Otherwise, it returns the appropriate character. 0 is going to be meaning that it starts with that string, right? So that's the reason, part of the reason we're using -1, and it's also kind of a common programming approach. The length of the string, and I'll go ahead and clear the output so that it's got a big reveal going on, right? Next, split and join. You potentially want to be able to take either an array, turn it into a string, which is what we're doing here, and there's those are basically doing the same sort of thing, just two different examples. And you may also want to do the opposite, where you take something that is delimited in some fashion and turn it into an array, and then you can access those elements of the array. Whenever you're looking at a string operations, you can go through and gets the various elements. I believe, and this is when it's probably going to go terribly wrong, you can do this and reverse the order of this string as well. So not too sure how often you would actually ever do that, but it is something that is there, just as the same sort of functionality that's available inside of a list. Moving back to the presentation, an example of what you're likely going to want to do whenever you're doing these assignments is take your previous milestone. In this case, I'm taking milestone 5's submission, and make a copy of it, changing the name to the assignment that you're currently working on. You're obviously, yours will look better than mine. I'm just kind of doing, this is like a sketch, so to speak, of what your assignment might look like. But this is an approach that one might use, is to basically start as a starting point, make just simply a copy of your previous submission. And then from that point, you go and start doing the work that is necessary to do the work. And in particular, you're going to want to add share per stock calculation, and it's a pretty simple thing to do. You're basically going to create a new column, deriving it from an existing column, right, and saving that value. And with that, we'll switch over to the Python sort of elements of this week. So go into the example of code that you have on your classroom, and this does break down basically those same steps, same as what we talked about. There's probably some variations on that theme, but it's not a bad idea. The process, you generally want to assign your file name as a variable rather than having hard-coded throughout the file. That way, if it changes, you have to change it in one spot rather than a bunch. Almost always you'll import the pandas library in and name it something like PD. That's not something you have to do, but it is something that people typically do. Next step is to read the data frame, the file into a data frame, and then derive a new column, which is average. And you did this early on, but you actually were doing feature construction and didn't even know it, right? So, and we can take a look at the first, and we can see the average out here, and that is the average price, basically adding the high and the low together and calculating the average. Your true stock market people would probably say that's probably not the right number. You should probably be using the suggested close. But if you assume that you purchased the stock and you happen to get it in the middle of the time that it happened between those two extremes, then I guess it's as reasonable of a number as any. It depends on what you're doing with your data, obviously. So the next step would be to set a flag based upon some condition, right? So we're looking for stocks that have the name Google and Facebook, and then we want to take that and essentially filter based upon it, so that DF1 will have those which are Google. So because flag 1 was Google, and so these are all Google stocks. The second is to do the same sort of approach for flag 2, which is Facebook. And you can take a look that we have constructed two different data frames. So we've essentially split the data frames together. The next step is to merge them back together on merge. You give it two data frames, you tell it on what column you want to do and how you want it to do it. In this case, we're saying an inner join. What that means is that records have to exist in both data frames for them to be combined. That's a very common way that you'll do joins. There are times you'll want to do some sort of left or right outer join. The reason is if maybe you want to care about the entirety of one series, so you reason you might see that. And then the last step here is to basically write it out, right? So we put it out to a file. And I didn't run that. Yes, I didn't run that, so I skipped a command. And then so from here, we've written out a file. Now suppose you want to have maybe what is that, $10,000 that you can spend a day, so you can spend 25,000 or 2,500 on each stock. So we're basically taking the amount of money per share. So that gives you a hint. You're wanting to know how much is it per share. And you want to know the number of shares. So the dollar amount divided by the price is going to tell you how many shares you're getting, and we're assuming that you can buy fractional shares. Then we can take a look at that produced data frame and see that it does now contain convenient for your index to be something that is truly a natural sort of index, right? So data is a good thing to index things by. With that, back over and talk about R. So we talk about R strings. The approach here is to do similar sort of operations as what we do in Python. It's structured a bit different because it's a bit older. grep is something that's been around for a very long time, comes from the Linux world and Unix world before that, and the basic idea is it lets you search within a pattern of strings. There's also nchar that lets us count the number of characters, but you'll notice here that it's not more kind of object-oriented in a way as what Python is. In Python, which is arguably object-oriented, you actually most of the time execute a command on an instance of an object rather than just call a function. Here we're calling functions, so it's a subtle difference in how the languages work. So it's an important kind of difference between the two, and something to keep in mind. I'm not too sure why I'm doing that, but making it a little prettier. So we can shift over and actually do this for real, assuming my R kernel is working. And again, this is an R notebook. You can see it up here, running inside of Jupyter. So let's restart the kernel and clear the output. So grep, very much like Appind, you have a string that you're looking for inside of another string, and it does appear also to be zero based as well. We're looking for 5 inside of 1, 2, 3, 4, 5. To me, the syntax seems kind of odd, but it's what I'm looking for within what, and that's the way to think about it. And then you can here find the various elements as well. It is searching within, what is that, a collection of strings as well. So grep, if you're a Linux person at all, you know exactly kind of what that's about. If you're not, no worries. It's just basically find, so keep that in mind. If you want to know the number of characters in a string, it's nchar. If you want to know the number of characters in a collection of strings, same sort of thing. We're basically creating essentially a vector of strings, and we're calculating the lengths of each one of those, which could come in handy. Oftentimes you want to combine together strings. R doesn't make it quite as easy as Python's plus, right? So with Python, really easy. You use string 1 plus string 2, and you have a combined string. Paste is what you do inside of Python, but it also has the ability to do something similar to a join, so we can paste together two things with a separator. And you can also paste together any number of things, so it handles varying arguments, technically speaking. And then you can also do a replacement or substitution of a string as well. Again, all these things are based upon the function pattern. You've also got the string split function that takes a string that is potentially delimited by something and returns back essentially a collection of strings. And then you've got your substring operation, which allows you to slice something from within a string. And I saw I had done that earlier, trying to make it pretty, and introduced a typo. So that'll tell you that it is pulling out this right here. So we're pulling out the 10th through the 14th character in that string. And the reason we're talking about things like string functionality is it is a common thing that one does. Very common to go through and interact with files that contains textual information. Sometimes it can be pretty simple stuff, like you're given a file that has a string that contains a first name, comma, last name, or last name, comma, first name, and you need to separate those into separate attributes. Sometimes it can be just part of data wrangling. If you have something that has varying type of delimiters, so you have a delimited string, meaning that there's simply a character being used to partition the string. So to say, yes, it's one big string, but within that string there's a way to decode it so that you can do something with it. That's exactly where that sort of thing comes from. Shifting over and taking a quick look at the deliverable notebook, a related string, this or notebook. This is what was supplied to you inside of your course room. Typical stuff here to figure out where my file is, and then I will load the file here. So we've read the file into essentially the data frame, and we can take a look at it and see that it looks pretty much like what we would expect it to. We can also then take that file and calculate the number of shares per stock, and you can see a double out here, which is the number of shares that can be purchased. You can buy fractional shares in some situations, but from a purist perspective, you typically have to buy whole numbers of shares, but that would make it even more complicated. You just would take the floor of it. So that's pretty much the aspect to consider with the things that were given to you. So now we can talk a bit about the deliverables. So you're given a scenario where you're interested in expanding your code base in your new consulting company that want to show how you do merging and combining of data in Python and R. And you need to support the characterization of your portfolio with some more stock sort of related stuff, such as the number of shares that can be purchased on a given day using historical data. The deliverable 6, your instructions here are to there's two different things you're submitting, and as always, make sure that you submit the source code, not just the write-up. So make sure that you're giving me the Python and R files that you actually ran. I need them so that I can verify them. In your first submission, you're going to use Python. You'll take the GAFA stock prices and create categories from your 4 stocks statistics in order to identify the number of shares that can be purchased with $10,000 for a trading day, which means you're splitting that evenly amongst the 4 stocks, so 2,500 per stock. This will rely on the combined 4 prices of the 4 stocks per day using advanced grouping functions in both R and Python programming language. Assume a portfolio containing equal numbers of shares in all 4 stocks. You will generate the number of shares purchased. Then your output will be the source code in a plain text file performing this first activity in Python. You need to turn in the source code as well as associated output from the test data. Using the R programming language for the second submission, you will take the stock price using your output file of your first submission and generate a distribution plot of the stock prices. You will output your output will include both the source code and the plain text, as well as your graphs. Your rubric, it's you want to shoot for that master column, and as a general rule, it's about additional validation, error handling, and so on. So make sure that you're doing some inspection of the data to ensure that the file was loaded correctly, that maybe the number of records is what it should be, that there aren't too many nulls, and so on, right? And then the second criterion, use Python grouping function to group the data together for analysis, include significantly more error checking logic to determine if the data was read correctly. And then for R, you want to read the file into a data frame, append Amazon, Facebook, and Apple, Facebook, Amazon to the data frame. So you're getting them all together, all 4 stocks. Include significantly more error checking logic to determine if the data was read. And then your last bit there is to do a distribution plot and then set some custom and advanced options on the graph. So don't just do the defaults, make it pretty. Set some things like titles and labels and so on. Moving on for a discussion of deliverable 7. And this is the purpose of this is to kind of tie it all together. That's the point, and these things kind of build all together so that deliverable 7 is reasonably challenging to do, but you should be well prepared. So the competencies that are demonstrated through deliverable 7 include setting up an analytics program or analytics environment, applying data structures, objects, and classes using built-in learning resources, utilize scripting and programming languages to read and write data files used in data science, utilize core programming fundamentals to achieve desired analytical outcomes, and employ advanced data structures, and then utilize advanced programming fundamentals. So we're near the end, so you're showing that you were paying attention. And then your scenario is that after doing some marketing, your organization was able to procure a potential customer who is interested in examining different sales scenarios to find the business model that is most profitable. You have been provided a set of sales data which has characterized clothing stores with a number of attributes along with the associated sales. Through the application of decision tree analysis, you are asked to actually build a model that will read in the data file, and after loading it into a data frame or associative array, split the data into two sets. One is over and one is under the median sales. So you'll need to determine what is the median sales for the data frame and then associate a flag with if it's above or below that value. You will then apply decision tree analysis in order to find out which attributes contribute to either high or low sales. So your instructions here are to take the Rossmann data set from Kaggle, and then you will either use Python or R, so or this time, not both, but or, programming language to read the associated data sets. Next, you're to load the data into either an associative array or a frame-based representation to make it suitable for analysis. I would recommend a data frame just because it's a whole lot easier than some of the others. Next, you need to apply the Python or R libraries, which may include but not be limited to CART model or the scikit-learn inside of Python. So there's whichever model makes the most sense for you depending upon what language you're using, and then perform the analysis and output the file containing only the limited feature set. So you're doing something called feature analysis and feature importance analysis. So you're figuring out what stuff here really matters. Note you only have a single submission, which will be your source code in a plain text file and the output that was generated with it. And it will be implemented in your preference of either Python or R language. So pretty big departure from what you've done so far in the course, right? Yeah, one language, pick one that you like, and then you only have to implement it one time. And it's not some sort of twofold sort of thing. The assessment or the rubric for this assignment is that you need to read data in using the R or Python language, include code to do significantly more error checking to ensure that data was successfully read, and then convert the data into either an array or a data frame in Python or R. And then you want to have some error handling and error checking. So you want to do the same sort of profiling of the data to make sure that it looks like it was loaded correctly, do some assessment of the data, maybe take a look at what the characteristics of the various values are, and so on. You then want to utilize an analytics tool such as CART to determine the factors that drive sales, include significantly more method of analysis such as regression and machine learning to determine the other factors that are driving sales. And then utilize R or Python to generate meaningful output and graphs, and to present the results of the analysis. So you want to make some pretty pictures, utilize more advanced options in the output beyond the default settings. So go beyond just the default plot, do some customization and optimizations of it. With that, I'm going to go ahead and try to open up an application called Orange. Orange is a data science graphically oriented language or environment. You can use it from inside of Python, or you can also use it in a graphical sort of way. What I'm going to attempt, and we'll see how this goes, is to kind of do something like deliverable 3 or 6 inside of it. So back here to deliverable 6, where we're taking some stock and we're doing some feature calculations. So we'll see how this goes. It takes a little while for Orange to come up, but I have started it. So give this a few moments. And while we're waiting, as always, if there are questions that you want me to drill in on, feel free to send them to me. If it's appropriate, I can address them in this forum, or we can always exchange emails, which some of you have been doing, which is great. And also, I have been encouraging you to be active in getting your submissions in, because the clock is ticking. And like the soap opera is sands through an hourglass or the days of our lives. Yes, well, this one has a very real end to it, so a very predictable outcome, especially if we don't get it resolved pretty quickly. So do be proactive and get your work in ahead of time, because you're going to end up where it will become unrealistic to complete all the assignments in the number of days that remain. So you want to avoid that at all cost. So what I'm doing is loading in the GAFA out. Oh, that's not what I want. I want the GAFA stock prices. There we go. And this has, you can see a nice little thing. We've got a categorical value, which is the feature. The stock, then we've got date, open, high, low, close, all that sort of stuff. So we can go ahead and say, yes, that's fine. The next thing we want to do is you could do some analysis. It should be popping something up. There we go. I think it's create our feature constructor. And this allows us to construct features, right? So we can say, we're going to construct a numeric one. We're going to call it average. And the expression is open plus close. And to be on the safe side, we'll put it in parentheses over 2. And we'll see how that goes. Okay, what did I do wrong? Unsupported. Oh. See, it thinks they're strings. Okay, so we need to change that to, what is it? Feature. And oh, I know what I need to do. It's over here. And this is the challenge with doing this live. It's not liking, maybe my file isn't good. Let's take a look at the file. Yeah, it ought to be able to handle that. Alright, so maybe there's another way. Function. Alright, let's try that. So it's a string, so we'll try float. Null. Alright, so maybe I need a different file. And to do some additional work here, we'll start off and do what I should have done at the beginning, which is a data table, so we can see what it looks like. It pops open and we can see looks fairly right. All right, that looks reasonable. But the question is there any, there's no nulls in close. All right, let's try that again then. There's another one we can do, which is data info. Okay, we'll try that again. So let's keep it simple and start off with fopen equals alright, so this is clearly not going to work. So let's see if I've got something I can open up instead. Alright, well, I don't want to waste any more of your time, so I'll take a look at this and see if I can talk about it the next time. If you have any questions about a particular module, if there's something you want me to revisit in the course, I'd be perfectly glad to do so. The main thing is for me to know where you're struggling, if you're struggling, so I can try to help you. So do feel free to reach out to me. That's what I'm here for. Stay safe, and we will speak again soon.